So, good afternoon, everyone. In today's class, if you remember, in previous class we have already completed the 8086 minimum mode and maximum mode of operation. In today's class, we will start the rest of the portion of the 8086, and hopefully, uh, my plan is that within tomorrow I want to complete the 8086 initial section. So, before going to the further discussion, I want to share the slide. Then we will start our discussion. So, if you see the previous class, we have already completed the minimum and the maximum mode of operation of 8086. Now, that is the last part of the 8086 according to our syllabus. That is called the multiprocessor system. That means the 8086, the different types of advanced processors are there, different I/O function that we can perform. How can you perform using the 8086 that you will study, that you will discuss under this article? So if it's the multiprocessor system, so multiprocessor system, that is this particular section is purely theoretical one, and you have to understand the basic thing. With the basic thing, you have to go with the details that are associated with the different portion, or that you are finding out different portion of the advanced processor that you will club together with the 8086. So multiprocessor system refers to the use of multiple processors that execute instructions simultaneously and communicate. So maximum mode of 8086, that is important, is designated to implement three basic multiprocessor configuration. So if you just, I want to highlight one thing. So if you see the maximum mode of operation that we have already completed, the maximum mode of operation of 8086, that can be implemented in the three basic multiprocessor configuration. First one, that is called the co-processor, and the processor name is 8086. Second one, that is called the closely coupled, that is the dedicated I/O processor 8089, and the last one that is called the loosely coupled, that is the multipass. Again, I am repeating the name. First one is the co-processor. Co-processor means if in bracket I have mentioned that is the 8087 is there. Next, the second point, that is the closely coupled, the dedicated I/O processor is there, so 8089, and the last one that is called the loosely coupled, that is called the multipass system. So co-processor configuration. First, we will start with the first article, that is the 8087. What is this? First, we will see, then we will discuss one by one. So co-processor configuration, it is the starting. Initially, the numeric processor, that is the 8087, is co-processor which has been specially designed to work under the control of the processor 8086. So that is, we can see that is the integral part of the 8086 processor. And which kind of processor this one is? This is called the numeric processor. The nature of the processor, because for the MCQ question, that is one another informative portion that you are getting, or the another information you are gathering, that is this 8087 is basically the numeric processor. That is attached, again I am repeating, that is the integral part of the 8086, and to support additional numeric processing capabilities. Features, now obviously we have mentioned that it is a numeric processor. So what are the different numeric functions? What are the different numeric features that we are getting, that I want to identify, or that I want to highlight? So first one, if you see, that is the feature, if you see the feature point, the first one is it can operate on data of integer, decimal and real types with length range from 2 to 10 bytes. See the range, a versatile kind of range we are achieving here. It can operate on which type of data, on the integer data, the decimal data, as well as the real type with length. The length is fixed between from 2 to 10 bytes. Point number 2, that is called its instruction includes some useful functions like square root, exponential, and tangent. So this is advanced type of operations, or advanced types of processing that we are fetching here. Point number 2, if you see, that is called its instruction includes. What are the inclusions are there? Some useful functions. What are the useful functions that we are gathering? Square root function, exponential function, tangent function. And the next one, that is called the point number 3, it is high performance numeric data processor. It can multiply to 64-bit real number, 264-bit real number that we can multiply using this particular numeric data processor. So co-processor configuration, 3 individual points already we have highlighted. First one, the numeric processor 8087 is co-processor which has been specially designed to work under the control of the processor 8086 and to support additional numeric processing capabilities. The features, already you have noted down 3 individual features. The first feature, it can operate on data of the integer, decimal, and the real time with length ranging from 2 to 10 bytes. Second one, its instruction includes some useful functions like square root, exponential, and the tangent. And the last one, that is its high performance numeric data processor. It can multiply 264 with real numbers. That is the 3 individual point already we have noted down. Next, the pin configuration of the 8087. If we see how many pins are there, already 40 pins. If you see the 40 pins configuration and 8086 NPX. Now we'll see the individual pin and we'll see what are the function of the individual pin that we are getting. So point number 1 to up to point number 40. So 40 pin configuration we are achieving in this 8087 pin diagram. If you see, that is the address or data, status ready, reset, clock and ground pins of the NDP are similar to the 8086 pins. If you remember the address bus and the data bus, the status ready, the reset, the clock and ground, these are the common pins. These are the function of the pins are already we have studied in case of 8086 processor. And I have mentioned one point at the initial portion of our class that 8087 is basically the integral part of the 8086, that is a numeric processor. So in this case, most of the pin that we have studied, that address or data bus, status ready, reset, clock and the ground pins of the NDP, that are similar with the 8086 pin. The other pins, that means what are the different pins, what are the extra pins configuration that we are getting, that we will discuss now. So BCP, BC signal from the 8087 is connected to the test input of the 8086. If we remember 8086 pin diagram, we have found there was a pin that is called the test pin. So in the test pin configuration, if you see the 8087 is connected to the test input of the 8086. That is the trial type of input, and BC signal from the 8087. Where is the BC signal? If we see the pin diagram here, we will find there is a dedicated BC, that is the pin number 23. There is a BC signal, that is the output that will come out from the processor. Come out from the processor means from the 8086. If you see the arrow, that is, this is the arrow of the BC signal. So the BC signal from the 8086 is connected to the test input of the 8086. If the 8086 needs the result of some computation, then the 8087 helps using this pin. So if the 8086 needs result of some computation, that means the extra results, some extra result fetching is required, if any moment from the 8086, then the 8087 will help using this pin. Next, RQ bar slash GT naught bar. First, we will see what is the pin number. Pin number 31. You see the 8087. Which pin we are finding out this RQ slash GT naught bar? That is the pin number 31, according to our pin diagram of the 8086. 8087. So RQ slash GT naught bar, that this request or grant signal from the 8087 is usually connected to the request or grant pin of the 8086. So one thing, another, though I have repeated this term, repeated this point in many times. In this case, also I am repeating the words. That is the pin number 31. If you see, that is the active low signal because bar sign is there. So the nature of the signal is active low. So RQ slash GT naught bar, that is this request or grant signal from the 8087 is usually connected to the request or the grant pin of the 8087. INT, that is the 8087 can interrupt the 8086 through this pin. First, we'll see which one is the pin number of the INT. If you see, the INT is the pin number 32 because the pin number is really important. Because if you see the connection diagram, or if you want to make the connection diagram, then you have to remember the pin diagram. Which pin you have to connect at this point, that you have to remember. So INT, that is a pin number 32 pin, according to the diagram of the 8087 pin diagram. So the 8087 can interrupt. That is the INT is basically the interrupt signal. Interrupt the which processor? Interrupt only the 8086 processor through this pin. Next, S2 to S0 bar. So if you see S0 bar, S1 bar, and the S2 bar, pin number 26, 27, and the 28. Another 3 active low signals are there. Pin number 26, 27, and 28. Again, I am repeating another 3. Obviously, these are the signals and the status signals, and that is the nature of the status signals are active low. So S0 bar, S1 bar, and the S2 bar. If you see the status signals, depending upon the combination of these three signals or the status signals, we are getting some highlighted dedicated operation. So if the S2 bar is 0, S1 bar is cross, means that is not defined, whatever may be the status of the S2 bar, sorry, S1 bar, and the S0 bar is again cross, that means whatever may be that might be 0, that might be 1, that will not impact. If the S2 bar is 0, then that is called the unused. Then the status, you have to remember the status that we have mentioned, that is the unused one. If the S2 bar is 0, then whatever may be the other pin status, that means the S1 bar and the S0 bar, that might be 0, that might be 1. Whatever may be the status, we are getting the status will be the unused one. Now, the second case, S2 bar is 1, but the S1 bar is 0 and the S0 bar is 0. Then also that will be unused. So, two unused status we are getting. First one, whatever may be the status of the S1 bar and the S0 bar, if the S2 bar is equals to 0, then that is called the unused one. And if again, another condition for the unused we are getting, if the S2 bar is equals to 1, but S1 bar and the S0 bar is 0, 0, then also that is the unused one. Next, the third combination, if you see the S2 bar equals to 1, S1 bar equals to 0, and the S0 bar equals to 1, that is called this. If you check the status, that is called the read memory. S2 bar equals to 1, S1 bar equals to 0, and the S0 bar equals to 1, then the status, if you check the status, that is called the read memory. Next one, if the S2 bar equals to 1, S1 bar equals to 1, and the S0 bar equals to 0. So obviously, if there is read memory, obviously write memory will be there. So the next combination we are getting, if you check the status, that is called the write memory. In the write memory condition, what we are getting S2 bar equals to 1, S1 bar equals to 1, but the S0 bar equals to 0. That is the write memory. And the last one, that is all the pins, that all the status signals, that means the S2 bar, S1 bar, as well as the S0 bar. If all the three status are basically 1, 1, 1, then if you check the status, that is called the passive. So this chart is really very important. That is the S2 bar to S0 bar. Though there are three individual pin, S0 bar is pin number 26, S1 bar is pin number 27, and the S2 bar is pin number 28. Pin numbers I am repeating again and again because the pin numbers are really important. Don't miss these pin numbers, because there is highly possibility for your upcoming exam, upcoming semester exam, that will be MCQ based. So this pin number, they might ask what are the pin number in case of 8087, what is the pin number for the S0 bar. So you have to keep the pin number, because you cannot guess this thing, that is a dedicated pin. So you have to just remember the pin number and you have to answer. So S0 bar, the pin number is 26, S1 bar pin number is 27, and the S2 bar, the pin number is 28. Now, depending upon these three status signals, that means the S2 bar to S1 bar, S0 bar, if you see the combination, we can define the status. Again, I am repeating the chart. S2 bar is 0. If S2 bar is 0, whatever may be the status for the S1 bar and the S0 bar, the status will be unused. S2 bar, if S2 bar is 0, then whatever may be the cross means whatever may be the status of the S1 bar and the S0 bar, the status will be unused. Next one, if S2 bar equals to 1, S1 bar equals to 0, S0 bar equals to 0, the status will be again unused. So two unused status we are getting. First one, S2 bar equals to 0, depending upon the irrespective of the value of S1 bar and the S0 bar, the status is unused one. If the S2 bar equals to 1, irrespective of the value of, if S2 bar equals to 1, S1 bar equals to 0, and the S0 bar equals to 0, we are getting again unused operation. The third combination we are getting, that is the 101. 101 means the S2 bar equals to 1, S1 bar equals to 0, S0 bar equals to 1. That is called the status. If you check the status, that is the read memory operation we are getting. Similarly, for the S2 bar equals to 1, S1 bar equals to 1, S0 bar equals to 0, we are getting the write memory operation. And the last combination, if the three pins, that means the three status signals, that means the S2 bar equals to 1, S1 bar equals to 1, as well as the S0 bar equals to 1. If you check the status, we are getting the passive operation. So this is a very important chart. Next, QS0 to QS1. If you see QS0 and the QS1, that is the pin number 24 and the 25. So 24 pin is for the QS1 and the 25 pin is for the QS0. So Q is not at the Q is on, what is the status we are getting? So these signals give the information about the operation QS1 and the QS0. So if the QS1 equals to 0, QS0 equals to 1, operation, if we check the status, that is the no operation state we are finding out. If the QS1 equals to 0, QS0 equals to 1, first byte of output from Q. Next one, again, QMT, and the subsequent bytes we are following, that is the QS1 equals to 1, QS0 equals to 0, that is the QMT, and the last one, that is the QS1 1 and the QS1 1, that is the subsequent bytes from the Q. So these four status of operations we are finding out in this case. So depending upon the value of QS1 and the QS0. S0 and the previous case S0 bar, S1 bar and the S2 bar are associated with the only status signal. But in this case, Q means that is the that is a queue, that is a sequence, that is a way, that is a path you have to follow. So QS0 and the QS1, that is the pin number 24 and the 25, depending upon that we can define the status. Next, you will find the interconnection of 8086 and 8087. So if you see the next part, that means this section, that is the interconnection of 8086 and 8087. That is a very common type of connection. In this case, what are the different components? One by one, we will check. So this is the 8086 and this is the 8087. So this 8086, before going to the operation of the 8086 and the 8087, what are the other components or the other units we are getting, that we have to check. So clock generator will be there. So clock generator, these things is connected with the, there is a synchronous. If you want to perform the operation in synchronous, because synchronous operation you have to perform two different processors. One is the 8086, another one is the 8087. So two different types of processor we are using here. So obviously the synchronous synchronization is an important parameter. So the clock generator role is very important. Next, 8288 bus terminal, bus controller is there. 8282 is there. So 8282 is basically depending upon the latching configuration. 8286, 8259. So different. One is the this transceiver section is there, as well as the interrupt controller. This is the latch that will depend upon the flip-flop operation. We have mentioned what is the configuration of flip-flop. If you remember the flip-flop operation, flip-flop based operation, we have seen. Just 1 minute. We have seen in case of 8086 basic operation mode. Just for your review purpose, I want to mention where you have studied this 4 different components. If you remember the pin diagram or the connection diagram arrangement, so you will find the different configuration, the different points you are finding out. In this case, also you will see the configuration that you are getting or that are adding with the minimum mode as well as the maximum mode operation. 3 fundamental units are there. If we see the transceiver and the latches, so these are the same component that we are finding out in case of normal 8086. In this 8087 operation also, you will see when we are combining this 8086 and the 8087, that is a type of maximum mode of operation. That is a that we have already initially mentioned. That is a part of the maximum mode of operation. So all the configurations, that is the control bus operation, address bus operation, data bus operation. If we see the sequence, all the operation that we are performing now that are associated with the maximum mode of operation. So if we see the interconnection of 8086 and the 8087, some points already we have noted. So MN/MX bar pin of the 8086 is grounded. So the 8086 is operating in this maximum mode. Just now I have mentioned. So this is the operation, that is the interconnection of the 8086 and the 8087. That means we are talking about this particular connection when we are operating the thing in the when we are operating the 8086 in the maximum mode of operation. So we know in case of maximum mode of operation, the configuration, or when we will go for the maximum mode of operation, there is a pre-counted or the pre-condition that this particular specification or this particular combination will be called as the maximum mode of operation. So MN/MX bar pin of the 8086 that should be grounded. So the 8086 is operating in its maximum mode. Point number 2, 8086 sends signal on the status pins and Q status lines. So obviously 8086, this is the status signal and the Q status lines. Without this status and the signals as well as the Q status line, we cannot accomplish or proceed further. So 8086 that will send the signals on the status pins as well as the Q status line. Point number 3, bus controller 828. If you see the bus controller that we are finding out 8288, if you see, that is the first point, the top of this particular configuration we have mentioned 8288 bus controller. So this is the bus controller we have mentioned. So this bus controller 8288 decodes these status signals to produce the control signals. The status signals will be decoded, and what are the different control signals that will be arranged, that will be generated, that will be depending upon this decoded sequence. Next point, the address lines A16 to A9 is connected directly from 8086 to 8087. So if you see the connection diagram, obviously this connection, dedicated connection slots will be there, and in this case the A9, if you see the sequence, you will find this, the A16 according to slot, so A16 to A19. In this case one printing listing is there, that is not the A9, that will be A19. So A16 to A19, this particular slot is directly connected, that is no multiplexing is there, directly connected from the 8086 to 8087. 8087 receives the same clock and receives signals. Obviously, I have mentioned at the initial portion, the clock generator, that is a synchronous type of operation. The same clock will be given to the 8086 as well as the 8087. No other clock, no separate clock will be given. The same clock frequency, the same fixed amount of clock frequency will be provided to the 8086 as well as the 8087. That is an important point, because two different processors will simultaneously going to be the operating state. So that is a type of synchronous operation that you have to perform or you have to go through. So that they have mentioned, the 8087 receives the same clock that and the reset. Not only the clock, the reset signal is also a vital signal, because when we want to reset the 8086, the same time the 8087 will go to the reset operation or perform the reset operation. So that two signals, one is the clock signal and another one is the reset signals. That should be same. Next point, the bus request of the grant signal from 8087 is connected to the request of the grant of the 8086. Again, there should be a matching technique. So the bus request of the grant signal from the 8087, that should be connected to the request of the grant of the 8086, because we just see the configuration when you have mentioned the request from the grant signal from the 8087 is usually connected to the request grant bit of the 8086. That we have mentioned when we are discussing about the pin configuration. We have highlighted this point. So this point again we have mentioned when we are describing the connection diagram. The next point, the busy bar signal from 8087 is connected to the test bar input of 8086. So that is also we have mentioned that is a busy bar, and another pin we are getting, that is called the test bar. So busy bar signal we have when we have mentioned, so busy bar signal from the 8087 should be connected to the test bar. So if you check the connection diagram, different operation we have noted down here. This operation already we have mentioned when we are describing the 8087 pin diagram. That is the same kind of thing, that is the same structure of thing we are following. So in this case also, when we are describing the operation of the BC bar signal from the 8087 is connected to the test bar input to the 8086. Instruction of 8087 are inserted in the 8086 program is as needed. 8086 fetches instruction bytes from memory and puts them in its internal queue, and 8087 also reads these instruction bytes and put them in its internal queue. So obviously there are two different type of status signal we have mentioned. One is the queue status as well as queue signal, another is the normal signal or the normal status signal. So in this case, if you check out this point they have mentioned, that is the instruction that we are getting from the 8087 are inserted in the 8086 program as needed. Whenever, depending upon the instruction, depending upon the different sets of operation that will be inserted. 8086 fetches instruction bytes from memory and puts them in its internal queue. And 8087 also reads this instruction bytes and puts them in its internal queue. I have already mentioned this is a purely theoretical portion. So only the points I am discussing, you have to note down these points, and these points will be helpful for your exam purpose. Whatever may be the pattern of the examination, that might be MCQ based, that might be broad question based. Whatever may be the pattern of the examination, the informations will be required. So 8087 decodes each instruction from its queue, and if it finds that it is an 8086 instruction, then the 8087 treats the instruction as NOP. Similarly, 8086 decodes each instruction from its queue, and if it finds that is an 8087 instruction, then the 8086 treats the instruction as NOP. So the NOP will be performed, or the NOP that will be decoded, or NOP will be basically performed when you are decoding that. There is a vice versa operation that we are getting the signal from the 8086 or from the 8087. That repeating upon that, we are the instruction will be treated as the NOP. The instructions are differentiated by the code 11011. The 8087 instruction code has 11011 as the most significant bits of their code byte. So that is the common code byte that we are maintaining, 11011. Depending upon that, the 8087 instruction code has 11011 as the most significant bit. That is called the most significant bit of their code byte. So again, what we have discussed till now, we have started with this particular multiprocessor system. So multiprocessor system refer to the use of the multiple processor that execute instructions simultaneously and communicate. So we are discussing this article under the maximum mode of operation. So maximum mode of 8086 is designed to implement the three basic multiprocessor configuration. We have just started with the first one, that is called the core processor, and the name of the core processor is 8087. Point number 2, that is the closely coupled, that is the dedicated IO processor, that is the 8089, and the last one, that is called the loosely coupled, that is the multi-bus. So three different designed or configuration we are performing in the 8086 which mode? 8086 maximum mode of operation. Then we have studied the core processor configuration, that is the first part, that is called the 8087. So the multi-processor, the numeric processor 8087, which type of processor 8087 is? 8087 is basically a numeric processor. Is core processor which has been specially designed, that is specially dedicatedly designed to work under the control of the processor 8086. I am again repeating, that is a dedicated type of processor. If you see the application of the 8087, that is a basically dedicated hands-on application with the 8086 we are getting. And the basic task of this processor is perform the numeric processor, to work as a numeric processor, or to perform the numeric tasks, the numeric operations. So under the control of the processor 8086, and to support additional numeric processing. Part of the additional numeric processing, we have already noted down the additional features of the additional numeric processing that are required in this case. So it can operate as data of the integer, decimal, and real type with length ranging from 2 to 10 bytes. That is the range from 2 bytes to 10 bytes that you can perform. Point number 2, its instruction includes some useful functions like square root. These are the new thing that we are finding out in the 8086 because that is a dedicated type of numeric processor. So its instructions include some useful function like square root, exponential, and tangent. Point number 3, it is high performance numeric data processor. It can multiply 264-bit real numbers. So that is a really remarkable point. 264-bit real number we can multiply using this high performance numeric data processor, that is the 8087. Then what we have discussed the 8087 NPX. If you see the pin structure of the pin diagram of the 8087, we are carrying 40 pins. Left hand side, if you see, that is a symmetrical type of format. Left side we are getting 1 to 20. Similarly, right hand side 21 to 40. So each side we are getting the 20 pin configuration. We have mentioned that the address and the data bus, status ready, reset, clock, and the ground pins of the NDP are similar to the 8086 pin, because that is again that the operations of the 8086 8087 is totally dependent or totally collaborated with the operation of the 8086. So the address and the data, status ready, as reset, and the clock and the ground pins of the NDP are, that is the 8087, are similar. No difference as such differences there between the 8086 and the 8087. The other pins, what are the important pins we are getting? Busy bar pin. So if you see the busy bar pin, just now we have seen the configuration. So in this case, this one is the busy pin we are getting. So that is the pin number 23. So busy bar, busy signal from the 8087 is connected to the test bar input of the 8086. If the 8086 needs the results of the some computation, then the 8087 helps us with the pin. Next, RQ bar slash GT bar. This request or gain, that is a same type of signal from the 8087 is usually connected to the request or grant bit of the 8086. INT, that is the interrupt signal or the interrupt processing or interrupt input signal. So the 8087 can interrupt the 8086 through this pin. Next, the very important some status signal configuration we have seen, that is depending on the combination of the S2 bar and the S1 S0 bar. So if you see, we have checked the depending on the S2 bar and the S1 bar and the S0 bar configuration, we have find out the status signal settings. So S2 bar, if S2 bar equals to 0, S1 bar equals to cross means whatever maybe the value of S1 bar. Similarly, whatever maybe the value of S0 bar is status is unused. When the S2 bar equals to 1, the next configuration we are finding out when the S2 bar equals to 1, S1 bar equals to 0, S0 bar equals to 0. We are again finding out the status is unused. But the status signal S2 bar equals to 1, S1 bar equals to 0, and the S0 bar equals to 1. That is called the read memory. Similarly, S2 bar equals to 1, S1 bar equals to 1, S0 bar equals to 0. That is called the write memory. And the last combination we are finding out S2 bar equals to 1, S1 bar equals to 1, S0 bar equals to 1. That is called the status is passive. Similarly, for the QS0 and the QS1, that is the status signal regarding the Q. So Q, 4 different operation. QS1 0, QS0 1, that is the operation no operation. QS1 0, QS0 1, that is called the first byte of opcode from Q. That is a similar kind of format we are finding out. We have discussed in case of 8086 also. Next, QS1 equals to 1, QS0 equals to 0, that is called the QMT, and the last one, QS1 equals to 1, QS0 equals to 1, that is called the subsequent bytes from the Q. Then we have seen the configuration, because the interconnection of 8086 and the 8087, that is the crucial part. The interconnection diagram is needed. So interconnection diagram, what we have done done nothing new. So we have seen the MN/MX bar, that is the maximum mode of operation. When that will be maximum, that will support the maximum mode of operation. When the 8086 MX/MX bar pin of the 8086 is grounded, so the 8086 operating in its maximum mode, because this interconnection will be performed. This interconnection operation will be performed when you are performing the 8086 in the which configuration, in the maximum mode of operation. Next point we are getting, that is the 8086 sends signal on the status pins and Q status line. Obviously, you have seen the fetching. That is the when the 8086 where the 8086 will send the signal, that will send the signal to the status pin and the Q status line. Point number 3, that is the bus controller 8288 decodes this status signals to produce the control signal. If you see the first part, that is the top of this particular connection diagram, one bus controller is there, and the name of the bus or the number of the bus controller is 8288 bus controller. So if you see the bus controller configuration, bus controller 8288, that will decode these signals, status signals to produce the control signals. Next point, the address line A16 to A19. If you see the address line, they are talking about this A16 to A19, this one, that is connected directly from 8086 to 8087. Next point, the 8087 receives the same clock and the reset signal. If you see the connection diagram, the same clock as well as the reset, two different signals. This is the synchronous mode of operation, the synchronous type of operation we want to get between the 8086 and the 8087. For this reason, the point is very crucial. That is the 8087 receives the same clock and the reset signal. Next point, the bus request or the grant signal from 8087 is connected to the request of the grant of the 8086 that we have already mentioned. The busy and the test the busy signal from the 8087 is connected to the test of the input of the 8086. That already we have mentioned in the initial pin diagram configuration. Depending upon that, the instruction of 8087 are inserted in the 8086 programs as needed. Depending upon the sets of operation, depending upon the requirement, the mapping will be there. 8087 decodes each instruction from its queue, and if it finds that it is an 8086 instruction, then the 8087 treats the instruction as NOP. Similarly, vice versa, for the 8086 also, 8086 decodes each instruction from its queue, and if it finds that it is an 8087 instruction, then the 8086 treats the instruction as NOP. The instructions are differentiated by code 11011. That is important because this particular differentiation will be really important. The 8087 instruction code has 11011 as the most significant bits of their code byte. That's all for today's class. Next class, what we will discuss, we will try to cover this up, this topic. That is the next topic. That is the interaction between the 8086 and the 8087. The theoretical instruction. We will proceed. There is a block diagram of the flowchart kind of thing. We will cover. We will complete this topic in the upcoming tomorrow's class. Tomorrow we have consecutive 2 microprocessor class from 11 AM. Don't miss the class. In this class, we will complete this particular interaction between the 8086 and the 8087 and the other operations, the other types of operations that we are getting In case of other modes of operation means maximum mode of operation, we have already classified three configuration set. If you see the initial part, coprocessor, we have started 8086. We'll finish this one. Closely coupled, that is the dedicated IO processor, that is the 8089, and the last one that is called the loosely coupled, that is the multipass. So we'll try to finish up these three modes of operation. If we able to successfully complete these three modes of operation, then the 8086 portion, that are the important part according to our syllabus for the 8086, that will successfully will cover. Then we will move to the next portion of our syllabus. Thank you very much for your attention. So that's all for today's class. Before ending the class, I have to collect the attendance. Then we will close the meeting. So for today's class, just 1 minute. Manish Acharya is present. Next, Arpan Thapa and Joseph Tam. So thank you very much. Tomorrow, sharp at 11 a.m. we'll meet again and we'll continue our discussion. Thank you. Thank you very much.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Goodbye.